Okay, I got a little energy practice problem for you, and it's right here. So it says a 2 kilogram mass slides down a ramp from a height of 10 meters, and then there's a whole slew of questions that it asks. It says, so what's the potential energy at the top of the fall? Kinetic energy, how about halfway down? What's the speed at the bottom? And then part D is a little funny. It says, if you wanted the speed to be twice as fast as it is at the bottom, how far up should it have started? So, whole lot of words here. The first thing we absolutely have to do is to make a picture before we can even begin to think about attacking this problem. So it says it's on a ramp. So we are going to we're going to draw ourselves a ramp, okay, and we're going to put the block on the ramp, okay, and it says that it starts from a height of 10 meters. Now the awesome thing about energy conservation is it doesn't, if you remember that little roller coaster demo we did, it doesn't really matter how the ramp got to, how the block got to 10 meters. All that matters is that it's at 10 meters. So it could be like on a curved path that looks like this. I could just even have it just hanging in the air 10 meters. All three of these problems are exactly the same problem unless I include something like friction, which I'm not going to do, okay? So, this is my picture of the problem. This is 2 kilograms. Okay, and now that I have a picture of the problem, now I can start banging these out. So the first one, it says part A, what is the potential energy at the top of the fall? Well, okay, gravitational potential energy is mgh. The mass is 2, so 2. The strength of the gravitational field, G, that's 10. And the height is 10. So this is 200 joules, okay? Then they want to know, what about the kinetic energy? Well, kinetic energy, that's 1/2 mv squared, okay? And, well, when it's at the top, it hasn't started moving yet, so v is 0. This is 1/2 times 2 times 0, or 0 joules. So a takeaway from this is that usually for these kinds of problems, the potential energy is greatest at the top, the kinetic energy is least at the top. And then conversely, when you're at the bottom, the kinetic energy will be greatest and the potential energy will be smallest. So we'll get to that. The next question is, how about halfway down, right? Halfway down. So maybe I'll make a new picture of that. Halfway down, it looks different, so I'll make a new picture, okay? This was 10, now it's at 5, it's halfway down. So same questions, that's okay. So we can say gravitational potential energy halfway down is mgh, so that's 2 times 10 times 5, and that is 100 joules. Now the interesting thing is, for the kinetic energy, it is 1/2 mv squared, and you might say, well, wait a minute, I don't know the velocity. How do I calculate this? Energy conservation to the rescue. The initial energy has to equal the final energy. The initial energy is equal to the final energy. I started with, I'll write E total. I started with 200 joules. I now have to have 200 joules again. If I add these two things together, I'd better have 200 joules. I have 100 joules from gravitational energy. That means necessarily that I must have another 100 joules in kinetic energy. Why? 100 plus 100 has to equal 200. That's what energy conservation means. If I had 200 when I started, I have 200 at every single point I pick. I picked halfway. I could have picked a quarter way, 3/4 of the way. Wouldn't matter. I'd always have. This system has 200 joules worth of energy no matter what state it's in. Okay? Next thing is it says, what is the speed at the bottom? What's the speed at the bottom? Okay, well, the speed at the bottom, I have kinetic energy equals 1/2 mv squared, and the gravitational potential energy equals mgh. Let's just look at, I know it doesn't ask about gravitational potential energy, but just think about what the potential energy is when it's at the ground floor. It's 2 times 10. If the height is 0, this is 0. So it's 0 joules worth of kinetic energy. But we always said that these two together have to add up to 200. That's how much energy our system has. So that means the kinetic energy has to be 200. It has to be 200 joules. So I now actually have a piece of algebra that I can solve. So I have 200 joules equals 1/2 mv squared. So this is 1/2 times 2 times v squared. That has to equal 200. So a little bit of algebra magic. You end up with v squared equals 200, or v equals the square root of 200, which is around 14, a little over 14. Okay? So that's our answer for v. Okay? The next part's a little funny. It says, if you wanted the speed to be twice as fast as it was at the bottom, how far up should it have started? Okay, so we said that the speed is square root of 200 at the bottom. That's what we said. But they're saying, what if it was twice that? What if the speed at the bottom was twice what we had before? So 2 times the square root of 200. How high up would it have had to have started? Well, something we can do is we can say, well, how much kinetic energy would it have had if it has that speed? We can calculate that. The kinetic energy would have been 1/2 mv squared. Okay, so this is 1/2 times 2 times 2 times square root of 200 squared. So this is, these two multiply to 1. If I square both things in here, then this becomes a 4 and this becomes a 200. This whole thing will end up being 800 joules. So if the speed were twice what it was, I would need 800 joules. Now this is interesting because notice I double the speed and that quadruples the energy. Before I had 200 joules, I double the speed, so V becomes 2V, and now I have 800 joules. And that is because of this guy. V gets squared, and so the energy grows as the square of V instead of as V. Okay? At any rate, I have 800 joules. I would have 800 joules if that were my speed. So I can say that at the very top, the kinetic energy would be 0. It would be all potential energy. And the potential energy would have to be equal to this same number at the top. So I could say the potential energy is 800, and that's equal to mgh. Okay? So that's equal to 2 times 10 times h. So this gives me 800 equals 20h, or you'd have to fall from a height of 40 meters. You'd have to be 4 times as high to get twice the speed at the bottom. Okie doke. I hope this was helpful. If you have questions, feel free to ask.